this is what pops up as the top hypergraph Python library. So I think I'm going to use that. Yeah, I think that's probably something we should do quickly. It's going to help me visualize stuff before we get into merging hyper edges and stuff like that. Like, and because these I'm afraid might also determine the way that we specify a graph. And before I fix that in terms of how the edges are specified and all that stuff, I prefer to do it this way because I have the feeling there's got to be a better way to do that. I think I might just as well, instead of keeping track of the qubits like that, maybe I should keep track of the qubits using sort of a hyper edges, like two special hyper edges, one for qubit 0, one for qubit 1, for example, right? So let's install these, all right? First of all, there's supposed to be a manual in here, documentation, but I think installing is just conda blah blah blah. So just like that, the minimal installation, an editable installation with access to Jupyter Notebooks. What does this mean, though? What does it say here? Installing HyperNetX. So it's the same. An editable installation. What does editable installation mean? Let's just use that. Oh, let's just hide the prompts. Oh, so I can just install HyperNetX. HyperNetX. Let's see if that works. And as this installs, let's take a quick look at how does this look like hypergraphs. So, sub modules, what algorithms? Sub modules package, homology. We don't care about algorithms, I think. The drawing package, hypergraphs, classes, hypergraph, no, classes, hypergraph module. So what does it look like? So, okay, so you can create a hypergraph like that. Okay, it has nodes and edges. So you can initialize it like these. And so it has nodes and it has edges. Okay, yeah. So that's basically. Okay, now the question is, I guess I can give it whatever I want, right? So I still can give it the complex numbers. Hypergraph. Okay, so from an interval of intervals, from an entity set, bipartite graph. Okay. Okay, we can try it like that. I think that's going to be a smarter idea. And how do I? So I create the hypergraph like that, and how do I paint it? So I guess so the only thing that I have to do is probably change that. So instead of returning a system like that, it just returns a hypergraph, right? So I would just go ahead and kind of create the hypergraph like that, I guess. Still create packages. So that just creates. So I guess that just creates qubit like qubit 0 and qubit 1. So these are the two first hyperedges, but we'll be adding more hyperedges. Those are just special hyperedges. And we want this to be an array of complex numbers. So you're gonna have multiple edges, but we're just gonna have one here and another one here. So that's it really. So this will really be system equals this, and then just return system, right? So using a hypergraph. So we'll call these, what are we going to call these library? HNX. Okay, so this is going to be an HNX hypergraph, and then from state vector. So we'll ignore this for now. We'll keep it like that. And what we are going to do in here is, yeah, so that's the system basically that we have. And now I want to print the system. And how do we do that? drawing rubber band module. Yeah, I think that's what we want. I guess that's the. So how do we do these? Drawing rubber band draw. So do they have an example here on how to do this? Visualization methods. Oh, there's a Colab notebook. It's there. Done. Import HyperNetX. I guess that's what we have to do, right? So we have to probably do import HyperNetX as HNX. NetworkX. What is NetworkX? So I also gotta install that, or is it already included in the installed packages? It's included in there. So okay, but it's installing it separately from NetworkX. So from NetworkX, the layout, and it's also importing Matplotlib. So I have no idea what is this though, this inline. But I'll just copy paste it. HNX drawing. What happened next is HNX, okay. And okay, it's just drawing draw, just like that. So that's what we do here is we just I guess we don't need these. I guess we don't need that anymore. So view, I guess I can cell, edit, delete cells, and I can just do the following, right? Draw the system. So, okay. Do I need to reload these, or is this gonna work? Let's hope it will. Apple is building the font cache. Okay, cool. Okay, what is it not finding? Pandas. This needs pandas? Does it really need pandas? Import pandas? Why? I guess that just works, right? Install pandas, yeah. Okay. Pandas is like data structure and data management, is it that, or pandas? What's pandas? Data analysis library. I guess they do that for some of the algorithms that are needed for hypergraph stuff. Why is that CPU so high? Oh my god. 15%, 18%. Like seriously. I thought I had it fixed, but it's still. Let's see, and then what? And then so maybe let's try to migrate some of these things. So um, where's the documentation? So we've got these in here. Hypergraphs. So the hypergraph module. So you do these, and then you can access the nodes and the edges. And once you have the so an edge is an entity set, and then we have the edges. Okay, but you have the edges. Okay, installed. But how do you get the nodes off one edge? I guess you can do that. Let's see. Oh, that worked. Now, let's hope this prints something nice. NumPy and the array, unhashable type. Oh, unhashable type. Is it? Can I work around this anyhow? Maybe what I need is just an array of 2 elements. You know what I mean? If I just use arrays, like if I just use like, and then whenever I operate with this stuff, I can always convert them into an NumPy array for the operation. But like, so essentially, just lists, an actual type list. You gotta be kidding me. But if I give it like, just like one or and another one, that's work. An accurate drawing doesn't have an accurate drawing. Hybernetics. Should have Hybernetics. Drawing. Drawing package. There's some examples here, or where's the call app? HNX drawing. JSON, NumPy, Pandas Network X. Port Hybernetics SH and X. Yeah, that should work actually. Module Hybernetics, that's not your drawing. You're kidding me, right? I'm not going to be able to find that. The drawing package. Let me restart the kernel. Maybe restart. Connect it. just to make sure it's been. Oh, there it is. So one, okay, but it counts as one element, so it's really using that as unique. So if I would give it like the 0, okay, so that does like that. So I should just, I think I have to just, you know what, I'll just, it's ugly, right? But so what if I just do like this? Can I escape this? No. So I guess I can use a string. The problem is if I use the same string, it's gonna, yeah, come on. Oh, maybe I can do, so np numpy array to string. Maybe there's just, you know, I can just use that array to string. So if I had the initial state is basically these, right? So we want to do this. The initial state is this, and so what I'm going to do here is just have array to string. Now I'll have to add something to make them unique, because that's going to just array to string. That doesn't have. Oh, np array to string. I'm stupid. Is probably np array to string, and I just do this, and I copy this here. Cool. Yeah. Okay. Perfect. Now I probably want to have. Because they should be unique within the qubit, right? So I can always append the qubit, right? So I can always just say Q0, and then we can do something like that, right? Yeah, that's ugly, but at least we can work around Q0. Sorry, that is Q1. Okay, cool. Because the thing is, within one branch, we are not gonna have the same node twice, because if we have it, can we? If we have it, it's already there. So I think we cannot have like a two nodes within a qubit that represent the same state, because they would just naturally be the same. So they would just connect. I think that's fine. I just need to maybe have like a maybe I just do how do I add a cell? How do I add a cell? How do I add a cell? Insert. That makes just whatever. Add insert cell below. Def to string. So actually, we'll just like encode, and here's encode state, and just give it the state, the qubit and the state. So qubit and state, and that basically state vector. So what we do is we return exactly these. Where am I? Where am I here? Right. So we return exactly this. So this is just qubit plus this, and then we have dev decode qubit, and we have like a state string, and we also have dev decode state vector, state string, or it doesn't matter, that could just be, we can just decode state, right? And so we have what this does is like, what can we do? How do we do this in Python? Split string. Split separator. Okay, so you just do like, and what does this return? What does this return? Okay, an array. So basically return state string split like that. I think that's what it returns. No. So basically, so this is S, and then what we return is return S0, and S1 will be, so NP string to array, right? NumPy from string. D-type float. From string. D-type. NP complex, so you can say from string state string, and then D-type equals NP complex. I think that should do the trick. Let's test this though. So encode state and decode state. So if I encode the state here, I should just say, you know, here just should be encode state, initial state, Q0 initial state, encode state. I'm just working around. I don't want to spend too much time on this. This is really just a prototype. So, but yeah, that should work for encoding. Yeah, that works. And what if I now want to retrieve these, for example? I'll just say I'll just try that, decode state. Maybe here, right? So print decode state, and I'll just give it like this. Does this work? string size must be a multiple of element size. What if we print as? I am stupid. I am stupid. I forgot to add this here. And so yeah, I'm not adding any. So now I have Q0 on these, right? And so string size must be a multiple of element size. So now we have, let's say, but that's okay. And then, so print s, and what happens if I print these? No, it's safe string, sorry. S1. So, that's what's breaking, right? String size must be a multiple of element size. So what if we just print S1? So how does this look like? S1 is just these, right? How can I... And that is not like from string containing the data. Oh, I guess without the brackets. That's what it's doing. So, and Python remove Carter from string. I think I'll just, this is really dirty, but this is really, really dirty, but yeah. String replace. Okay, so I can just say yeah, but I don't think that is, I don't know if this is gonna work out. So basically, what if I just say replace? Can I give it like a list of characters and say replace these and these for these? Oh, I guess I just have to concatenate that. So I can just say replace these by that. And now I can just add this one here. Okay, cool. Let's see if that works. So we have these in here. So if I take that and I put it here, and I try to print that all. So maybe, you know what, the encode just should be You should be, come on, like you should, if you can turn something like into a, you know, like if I can just say print, so if I can, so it's printing me D string, right? Because array to string, that's what it does, right? Python array to string and from, okay, not Python, is that, no, it's just NumPy, so string without brackets. Oh, maybe that's enough. No, but we know that doesn't work. From string, like I want to, exactly, that's what I want. That's what I want, exactly. Work for me. So, image, what the heck? From buffer. The braces to get the elements just separated by some separator. Oh. Serialize a NumPy array with complex numbers. Isn't there an easy way to do that? JSON encoder. No. Data serialization. Maybe. NumPy SNP. So import JSON, NumPy, JSON NumPy object hook. What is all this stuff? This is too complicated. How to serialize an array, please fill with complex numbers. I don't want JSON, just one whatever, like just want a string. Ah, come on. Yeah, I guess I'll just look. I guess I'll just. So what do I get? I can do this by hand. So I get these, right? And so what if I just encode phone numbers? Four numbers, sorry. So if I, instead of doing these, I have the state vector. And so what I will do is I will just so I have a state vector, which is basically a complex array. It's an array of two complex numbers. So basically what I'll just, what what I'll just do is so the real 0, right? The Emac 0, the real 1, and the Emac 1. Those are the 4 components that I want to encode. So I'll just say state vector 0 real, right? And go on, and then let's just go on. This is Emac, and this is Emac. And so all I want to do is I just want to basically, you know, kind of, yeah. So just get like, just get a real 0. Let's just use something like these, okay? So real 0. So real 0, Emac 0, real 1, Emac 1. So this is yeah. Let's see if this works. String, not numpy float. Okay, so can I just do this? Does this work? The other way around. How do I cast to string? I keep forgetting this. Python cast to string. Just a string. Okay. So I just string like that. Let's see. Let's see if this works well. Okay, so now we have those things like that. Cool. So, and what I want to do now is we split that and we have S0 and S1. So S0 and S is S0. And so what we want to do is we want to, so I now want to do a so state components, right, is S1 split by this. Where am I? I'm opening. Why did this open Cortana? I don't know. We have the state components, and now I want to make basically an array of complex numbers. Yeah. Where each component is a complex number. So numpy complex number. How do I do this? Specifying both parts. Oh, just the function complex. So I can just say np complex and np complex, and I just can say, you know, state component 0, state component 1, and this is the same but 2 and 3. God. That should do the trick. And it shall allow me to return that. And if I, what am I doing here? Decode state. Okay, yeah, let's see. No, it's not a complex. Well, of course it doesn't, because it's an M. First is a string. I'm sorry. So how do I convert array of strings, floats, numpy? I guess I just do. I guess I just do. I guess I just do array. State comp t type float or something like that. Can this be done like that? Yes. Yes. Okay. Cool. So this prints well. Okay, good. So we have a way to encode and a way to decode, and it's taken us 40 minutes. Okay, cool. Well, we have these, right? So now we can print these things, and then let's do again the function to just apply gate, right? So how do we do this? Okay, so now we need to get so we need to get from like an edge that's called qubit, and that's where we get the nodes, right? So I need to refactor these, and then we'll refactor these. Because now we don't need to keep track of nodes and stuff separately. We just, what we just need to do is we need to access the. So first of all, what we need to do is we need to have so Q0, which is basically, you know, the edge 0. That would be not the other way around. So how do I get the nodes? With edges, I get all the edges, right? So with edges, I get an entity set. Okay, entity module. How do I... So first of all, I get the edges by saying system edges. Cool. So then I get an entity set. So how do I add element, children, clone? You can clone one, that's cool. Depth, elements, so elements to the entity. Elements, so elements, and those are the entity. And I would just say for entity in edges. Basically, I'm commenting these, and I just say print a. Okay, so and we apply a gate. So we do system equals apply gate. We're not like that's not gonna apply any gate really, but I'm just say Q0 the edge gate and then see what happens. So this is system is not defined, system is defined. Well, system is here defined. Why is it not defined? System is defined. System. There you go. Q0 and Q1. So you get those things like that. Okay, but now I want. So I'm getting the edges, but now I want the nodes of an edge, right? How do I do that? Can I just say elements? No. Edges. So this is just string. How do I get the nodes homology basics? Maybe in the basics tutorial. I want to get the nodes of the edge. So I need to refactor these as well. Draw nodes, edges. Shape. Size. Neighbors. Connected components. Collapsing nodes and edges. I want to know, come on, all the nodes of an edge. I guess connect components of Hyper because edges can intersect in a number of nodes. The connect components can give different levels of connection strength. That's not what I want. H and X get nodes of an edge. I don't know, there's something. Graph. Yeah, that's the same question I'm having. Answer. Edges. A specific edge in the graph is just a tuple of nodes with an optional weighting. Oh, so edges. So edges just gives me these. And so what does this print? Yeah, but that just prints Q0 and Q1. That's not what I want. Print edges. generate object entity. Edges. Network X. Okay, but that's okay. That's Network X. That's not what I, because this is basically built on top of that, right? Oh God. Hypergraph. Entity set. Entity A. Entity B. Okay. Hypergraph. Get item as degree. The hypergraph module. Edges. The edges just gives me these. I want to know. That's not what I want. Add nodes to edge. Okay, there's all this stuff. Collapse edges. That's cool though, because it can, maybe the collapse edges will actually help me. Collapse nodes and edges. Components. What are components? What is components giving me? So oh, cool. Okay, so it's giving me these. It's giving me, no, what is it giving me? The edge and then the stuff in here, like the node, right? If I, okay, so if I add, let's try and add another state in here. Yeah, well, it's the same state. I'm stupid. So what if we give it, like another, okay, yeah, okay, so now it's giving me these. Okay, so the components really gives me the, yeah, the edges. Components. I don't know, this is just synapse connected components. Maybe that's the way it's defined, right? Hypergraph components. Maybe these are pairwise connected, but yeah, okay. So components, just all components, and connected components is, yeah. Okay, cool. Yeah, but that makes sense. So what I'm doing is I'm getting the components, right? So I'm getting the edges, and for each edge, right? Now I want to decode the edge. So what I want to do is I want to use decode state, and that gives me, yeah. So so state is basically decode state E, right? So now I have the state E. Print E state. Split. Mm. Mm. Okay, note, because these could be multiple elements. So now we should just basically say for node in E, get the node state by decoding the node, and then print that. State's not defined. Node state. There you go. Okay, cool. And so now what we want is apply the gate in here. So what we're doing is, yeah, we have new states, right? So we take the new state, we do np dot of gate and node state. One. Let's print this. Cool. And so, and now what we do is, yeah, by the way, let me just get rid of these. Okay. So, new state. And now what we do is, so now we kind of have to, oh, how do we do this now? How do we make the modification? So we need to basically, do we just do the same thing and we just rebuild? I think we just rebuild the hypergraph again, right? So we just rebuild the hypergraph, I think. I know it's inefficient, but let's see if it just, because I could just add, remove and whatnot, but like I have new states, I'm just adding the new states in the new states, right? And then the only thing that I do is oh, and I only do these, by the way, if node state 0 equals qubit. That's important, actually. So it's really just this big object that we're trying to recreate, right? So it's really this big object that we're trying to recreate. So what I have to do is, oh come on, what's wrong with this? So what I have to do is that seems really inefficient, but it's a new hypergraph. It's a new hypergraph, a new age, new age. And so what I do is so is this an array inside here? Where is that? So that's an array. Yeah. So I'm just gonna so new age basically plus node state 0. All right. This is an array, so it's a list. Okay. So I'm just adding that list in here, a new age, and all what I'm doing is okay. So if it's a qubit, then we apply the gate, right? So otherwise, I would say new state is just the node state, right? If we apply the gate, then we apply the gate, and then what we do is we do here so to these we append this new state, as in like encode state, right? But we got to encode it with a qubit in there. So we got to encode it with the qubit. So this new state is for this qubit. Exactly. I think that's what it means. So get the components. So get the edges, then get the nodes, and then decode the node state. We don't need to print the node state, and then we create an entry for these okay, but this is this is a bit wrong, because what I have to do is I have to make sure that I only get the special components. But anyway, so I get the node state. I prepare these in here, new age, and then that's like an empty array, and then that is the actual state in new state. If this equals qubit, we apply the gate, and then we append for these. So now basically what I gotta do in here is print new age. Yeah, that looks about right. I mean, that doesn't look good though, but and so what we should return is basically a new hypergraph, not the system. Yeah, okay, so something has happened here, but it's not what it's expected to happen, okay? So what is decode state doing? Supposed to. Oh. Why is it, what is it returning? An array of type complex. So let's print these, and then let's print new state. So this is these. Let's apply the NOT gate. Okay, something's not working right. Something's not working right. Wait a second. So first of all, let's not apply this gate. We have these. And if we apply the gate to Q0, right? Let's just let me stop this for a second. Okay, sorry, I just thought it for a second. Drink some water. And where was I? So I'm having this. I'm printing the notes, the node state, right? This is this, which is wrong. Why is it like that in the first place? So node state. Oh, this is 2-3. That's the wrong. So that's a mistake for sure. That's a mistake for sure. Okay, so now we have 1010. Q0, Q1, but I don't understand why it pops up like this. So that's wrong. It's not qubit, but it's exactly. This is how we should encode it. Okay, yeah, okay, cool. And now we will apply the operation. Yeah, worked. Okay, it worked. So we have, this is in the 0 state, this is in the 1 state, exactly. So that is applying, but again, that is applying the gate to all the edges, and it's considering all the edges, and I don't want, so it should only consider the component edges, which what I will probably do is I think they'll just be prepended by, like, just qubit, right? So we'll just do, the edges will just be like these, okay? So that's just going to be qubit Q1, qubit Q1, right? So they're going to be preceded by the qubit thing here. Qubit Q0, qubit Q1. So what we will do is, yeah, maybe just like, should call it just like this. Okay. That's not it's not different than whatever. So Okay, so what I mean is qubit. Okay, yeah, what I should do, okay, so and basically what I should do is this is really dirty, okay, but like all the components and all the edges, and it's just like if so if no, um not in E, so that's the what I should take a look is the edges. So if I print E, am I being stupid? I think that's just it's fine. I want to go through all the edges. Doesn't matter. No, I just want to go through the qubit edges. It doesn't matter really, does it? Like if I'm just prepending stuff, that is already like if all I'm doing is if I'm encoding these in the nodes, I'm already telling okay that node is from the qubit 0, that node is from the qubit, yeah. So can I just like have a hypergraph from an entry set, from a list of iterables? So a hypergraph must have at least one edge, does it? That's what I don't know. I don't think I need to. If I'm encoding 2 qubits like that, that should be kind of fine. Because I'm just, what I need to do is I guess I just need one system. Then I just need basically one edge called system, right? And that's it. And that's encode state. Encode state, system. So that's all I need. And so all I need here is in the apply gate is just new system. System, right? And I just need to append everything to the new system. So regardless of that, this is just redundant. So I'm just doing new system, new system. New edge is not defined. Where's new edge printed? Yeah, that's not needed. New system. System. Yeah, that's it. So that's our system. It's qubit 1 and qubit 0, right? If I want to add like another node for qubit, like for example, That's going to be excited. I'm going to make like an excited state, right? And that's going to be these, right? And if I just make like, you know, this could be in the excited state, the qubit 0. Yeah, then I just get like for qubit 0, we've got 2 possible states. Okay, so I just and whenever I want to do stuff, I just go through the system edge, right? I get the system edge, and I do that. And now I can still add edges in here. So that's just the system. Maybe it even pays off to simulate it like these. Maybe it's useless, but maybe it just pays off to just say, yeah, those are the. So we've got like a system edge that basically groups all of it. Okay, we'll leave it here. So we've refactored the Polite gate, and now we got to refactor these to use HNX. Cool. Git status, git add all, git commit. Support for HNX. Yeah, and I'll just push that. Bye-bye.